Okay, good morning, good afternoon, good evening, good night, depending on when you're watching the video. So today we're going to work through exercise number 2 from slide 6 in lecture set number 3. So in this exercise, we are working in a fairly common probability situation. We're going to break down that particular situation using an illustration of the sample space. And then we're going to work through some fundamental style probability problems to illustrate how we can work with the sample space for this experiment. Okay, so the scenario here, we have 2 fair 6-sided die are rolled at the same time. Give the sample space for this experiment. All right, so we know that the sample space is a list of all of the possible outcomes that can occur each time you conduct the experiment, which in this case is rolling the 2 die at the same time. So a sample space is simply a list of all of the different outcomes that can occur when you conduct this particular experiment. There are many different ways to write out a sample space. You could write it as a list. In the case of die rolling problems, I prefer to use a tabulature to illustrate the sample space. So that's going to look something like this. So I'm going to have the outcomes for each die running along these axes here. Okay. So I'm going to put die 1 here, and I'll put die 2 here. Okay, so each die contributes 1 of 6 possible numbers. All right, something looks like this. Okay, so when we roll the die at the same time, we're going to observe 1 number from die 1 and 1 number from die 2. So one of the outcomes could be 1, 1. Okay, another outcome could be 2, 1. Another outcome could be 3, 1. Another outcome could be 4, 1. Another outcome could be 5, 1. And another outcome could be 6, 1. So these are 6 possible outcomes. And then we might have 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. And then we might have 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3. I'll get rid of the commas in between here, just so this isn't quite as messy. All right. So now we see 18 different outcomes, but there's still another 18 that we have to enumerate. So we have 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4. And then we have 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. And then we have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Okay. So for the experiment where we roll 2 die at the same time, this is our sample space. Again, the sample space is a list of all of the different things that can happen each time you roll the 2 die. So we might observe 1 and 1 together, which is snake eyes. We might observe a 5 on the first die and a 4 on the second die. We might observe a 3 on the first die and a 6 on the second die. Any one of these 36 different outcomes is possible each time we roll 2 die. Okay, in part B, it asks, what is the size of the sample space? So here we have capital N is equal to 36. Because you can see from the table in part A, there are 36 different combinations that can be observed each time you roll the die. Okay, in part B, now we're working on basic probability problems. What is the probability, what is the probability that both die show a 1? Okay, so here we can write the probability that we observe a 1 and a 1 is equal to little f over capital N. So our fundamental probability. Little f counts all the ways that you can observe 1 on the first die and 1 on the second die. When we look at our table, we can see that there's only one way that this can occur. So this becomes 1 over 36, which as a decimal is equal to 0.027 repeating. Okay. So each question is essentially going to follow this same illustration. Part D, what is the probability that only one of the two die shows 1? So we want the probability of observing a 1 on only one of the two die. Okay, in this case, I'll use green to illustrate. So we can see each of these 5 scenarios here and each of these 5 scenarios here correspond to a situation where there's only one being shown. So we have probability only one die shows a 1. Okay. This is going to be equal to little f over capital N. All right. And then that gives us 10 over 36, which reduces to 5 over 18. Okay. And then 5 over 18 is 0.27 repeating. Okay, part E. In part E, it asks, what is the probability the two die show the same number? Okay, so in this situation, we're looking for all the different outcomes that show the exact same value. So we can see that 1, 1 is 1, and then we have 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay, so probability 2 die show same number is equal to little f over n, which is equal to 6 over 36, which is equal to 1 over 6. All right, and then 1 over 6 is going to be half of a third, 0.16 repeating. Yeah. All right. Okay, and there you have it. So in this illustration, we have seen an illustration of how to write out a sample space. Again, a sample space is simply a list of all of the possible outcomes that can occur in an experiment. In this particular case, our experiment is rolling 2 die at the same time. So the outcomes, or there are 36 possible outcomes each time you roll that die. And then we looked at some basic probability problems or fundamental probability problems that allow us to count the number of outcomes within the sample space and then divide by all possible outcomes to find the probability of interest. As always, if you have any questions, please let me know.